Alright, folks, last question of the day. Let's go. Question 6. Right. Determine the single force that can be applied on the rod AB such that it will give rise to 0 resultant at a fixed end of A. Okay? Essentially, what they're asking, they're basically asking for everything to be net 0. What do I mean by that? Force X equals to 0. Force Y equals to 0. And moments about A equals to 0. Alright. So we now know that the force acting on A is, I'm just gonna point up and right and clockwise, because that is muscle memory. I always like to try to keep things positive. I understand that for this module, anti-clockwise is positive, but I'm just gonna put clockwise here. It doesn't matter, okay? Like the TA said, polarity doesn't matter. No one gives a shit about it. Okay. So let's first find X. Okay, I'm going to try use red color. So X, we have 300 because it's acting in the X direction. We have this 500 bad boy, and then we have this 250 bad boy. Now, does distance matter? Does the numerical value matter for the distance? I'm just repeating myself. No, it doesn't. Okay, because we're just finding it in general of X axis. So now we are going to assume that positive is in the right direction. Okay? So resultant X force equals to, take note that all these 0 is they want A to be 0 resultant. It doesn't necessarily means that whatever on this diagram right now will give you resultant. No, it basically trying to say like how much should A produce so that the forces along the x-axis is 0, in the end becomes 0. The forces along the y-axis in the end becomes 0. It not necessarily means like, oh, this diagram itself have to be 0 even without A. Okay, so let's just go from bottom up. So at the bottom we have 300 in the left direction, so in this case it's minus 300. Okay, and we're just going to add a plus. Oh, never mind, the next one is also in the left direction, so let's just make it a minus. So we have 500, but remember this 500 is slanted, so we need to change it so that it is along the x-axis, which is basically 500 cosine 30. And last but not least, our last force is along the right direction, so it is gonna be a plus. Plus what you ask? Plus 250 of what ratio you ask? Because going in the X, we are looking at the horizontal one, which is 4. This 250 is going along 5, so we do 4 over 5. Equate this. What is the resultant? Let me press my calculator. You get negative 533 newtons. This negative doesn't matter. It basically just means that my resultant force is acting in the left direction. Okay, let's go and put left. Next, we're going to use green to do Y. Same thing, resultant Y. Let's first identify, does the 300 have a Y? No, it does not. Okay, does my 500 have a Y? Yes, it does. Okay, does my 250 have a Y? Yes, it does. Oh, sorry, it's going downwards. So now we're gonna take positive is going up. Right, let's go up to down, sorry, bottom to up again. So the very first force we'll be looking at is a 500. Since it's going up, it's positive, so 500. Previously we did cosine 30, so now we just do sine 30. My 250 force is going downwards, so it's going to be a negative 250. All right, same thing. What's the bracket? Going downwards, we're going to be looking at 3, so 3 will be on top. Going down is a 5, so we're going to do 3 over 5. Compute that in. What are you going to get? 3 over 5. 100. Okay? So, now let's find our moments. Now this is going to be a pain in the ass. Yeah, it is going to be a pain in the ass. Hold on. How do I crop you? I don't know. Okay, whatever. You don't really need to see those lines anymore. Okay. So moments. Okay, how about this? Now we are going to solely look at moments, okay? Anything in the anti-clockwise, we will use green. Anything in the clockwise, we use red, alright? So, let's first try to identify, same thing, bottom to top, with respect to A. So, let's look at our 300 Newton first. 300 Newton, you are now going in the left direction, okay? I'm going to use blue as neutral first, going here. And this will give me anti-clockwise, yes, why did I pause that? Anti-clockwise. So, I now have 300 Newton going the anti-clockwise. I'm just going to label this as 1, okay? Now moving up, let's look at our 500 Newton. This 500 Newton have 2 directions. One here, and one going up. Can you see it? I'm just going to draw it really thick. Okay? Alright. About A, the one that's going left is also anti-clockwise. So I'm going to put 2. How about the one going up? Notice how there's a 0.2 meter difference, or not say difference, distance. So that means there is a moment. It's not parallel to A. It is away from A by 0.2 meters. So there is a moment. And in this case, this is going also this is going clockwise. This is going clockwise. Bro, the brain fart is real, bro. I'm gonna label this at 3. Right, let's look at our last force, which is 250. Same thing. Let's draw the forces. Okay, let's look at the downwards arrow first. It is going in the clockwise. So 4. Damn, why are you so thick? Then the one that is going right side, it is clockwise as well. So 5. There you have it. Do we have any more? Nope. Alright, so now we need to know that our moment will have 5 forces contributing to it. So let's use the blue ink now. It is a nice color, I hope. Moment about A equals to, let's do the green arrow first. Alright, it is 5. Okay, so green arrow, we have 300 times 1. Okay, you know what? Let's make life so much easier. We have 1 plus 2 minus 3 minus 4 minus 5. Okay? So we have 301 plus we have a 500 cosine 30 times 2 because it's 1 plus 1. And now it's our minus. We have 500 sine 30 times 0.2. Okay? Minus, let's look at our 4. It is 3 over 4, 3 over 5, 250. What's the distance? We have 0.5. And then minus our last one, which is 4 over 5, 250. Distance of 1 plus 1 plus 1, give me 3. Alright, my moment should be, let me just go ahead and calculate. Oh, did I put minus? Oh yeah, I did, okay. I don't know if you can hear me pressing my calculator. It's a very old calculator. Right, boys, we now have 441 Newton meter. And this is my moment. But we're not done yet because we have yet to find where our resultant force can be placed at to give me this moment. Okay? So let's first find the resultant. And we need to also find let's find the resultant. And remember what we need to find? We need to find the magnitude of the resultant as well as the direction that the resultant force is pointing at. What do I mean by that? Remember triangle rule? Because your total x and y, your y is 100, your x is 533. In this case, it's negative, so it's technically supposed to be this side, but whatever. Resultant will be basically this force, which is, if you ask me, it just forms a right angle triangle. Pythagoras theorem, boys. So resultant equals to negative 533 squared plus 100 squared, which should give you this number. I'm too lazy to press my calculator at this point. I'm sorry. And then for your angle, it's basically tangent resultant of y over resultant of x, which I will press my calculator because I want to confirm. I want to confirm. Okay. You have to put in the negative as well. Okay. You have to put in the negative. You get negative 10.6. So what does that mean? That basically means that if this is my x-axis, my resultant force is downwards. So this is 10.6. Okay. Then now, how do I get my distance? Remember from question 5 or 5? Do you have your moments? Yes, you do. Do you have... Okay, you want to find D, so you don't have D. Do you have F? Oh my god, you do! So you can find your D, which is basically 441 divided by 542 cosine negative 10. And if I'm smart enough, which I hope, oh my god, you get it 0.827 meter from A. And there you have it. Okay, let me just briefly explain again like why they want you to find this distance. So human nature, we are very lazy. And how lazy are we? Very. Okay, what do I mean by that? Is imagine this is your rod or this is your bar. Okay, this is point A. Human nature be like, I don't want to draw resultant force R and I don't want to draw moment. I just want to draw one arrow because I am stupid and petty. So moment about A, if I were to draw my resultant force on A, there's no moment. I can't find a moment. So I have to draw a moment. But I don't want to draw the moment line because I'm lazy. So how do I induce a moment but yet not draw the moment arrow? I shift my resultant force up, creating a distance, which if I take the perpendicular force times the distance will give me the moments. So this is what I was doing over here, okay? So this D is basically how high should I shift my resultant force up so that it gives me the moment and I don't need to draw the moment arrow. It sounds damn stupid, I know, but that's what they want, okay? That's what people want. We are stubborn creatures.